Okay, good morning, everybody. Hello, hello, hello. How is everybody doing this morning? I hope everybody is doing well. Good morning. We're here for another rip-roaring lesson of Math 120, some statistics. Hopefully, everybody had a wonderful weekend. Hey, good morning to you, Alex. I hope you're doing well. How was your weekend there? Hopefully, you're ready for another day of stats. Yes, some stats. Yeah, actually, it was my weekend was okay. It was a little rough. It was a little rough. Um, I was always ready for some math. Yeah, I was actually mostly in my bed most of the weekend, so I got uh I got the flu shot and I got the booster shot at the same time, and it just wrecked me. So my plan was to be like my plan was to actually, update your grades and stuff. That was my plan for the weekend. And then after I got that, it was like, well, I'm just gonna be in my bed. So that's pretty much where I spent most of my weekend, was in my bed. Even yesterday, I was still a little bit off. I'm feeling a lot better today, so it took me like a good couple days to kind of get over it. But yeah, yeah, it's not a fun combo, but it's important to get it. So I want to be fully vaccinated, make sure I am, fight against the flu and all that stuff. So I am feeling a lot better today, though. I woke up and I'm like, oh yeah, it feels pretty good. So, yep, that's where I'm at right now. That's where I'm at right now. Not too shabby crabby. How about you? Hopefully, I don't know if you've gotten your booster shot or you gotten vaccinated. It doesn't matter actually, to be honest. But hopefully everybody's okay and doesn't have that nasty virus. That's the only thing I hope. Still recovering? Yeah. Oh yeah, that's right. You did have it. You're finally feeling better? Yeah. It took my mom about a time to start feeling better. Coughing and bedridden and just feeling like general ass for like a good 10 days. Glad you had energy though to come out to these streams. It's actually one thing that's a blessing, I suppose, is that you could at least stream, at least come to the stream. Jasmine, good morning to you. How you doing? How we doing today, Jasmine? I hope you're doing well. Actually, I will say I'm better than most. I'm vaccinated, still not. Yeah, it's true. I will say this. I will say this, Alex. If there's one thing that's actually good in this situation, is that you're able to come to class and you don't have to worry about somebody looking at you while you're majorly sick. So you can just like come straight to this channel. Don't have to worry about it. Don't have to worry about a camera being focused on you. Just do the class. Um, I'm doing great, Jasmine. How are you? I'm just doing fantastic today as compared to a couple days this weekend. Yeah, I was just telling Alex that I was pretty much in bed most of the weekend because I took the booster shot and the flu shot. So that's pretty much where I was at. He's still 2 weeks behind now? Oh, wow. Yeah, I'm feeling better. It's just I was gonna get to your grades this weekend. I was gonna get to everybody's grades this weekend, and I just could not. Like, Saturday kicked my butt. And then Sunday was even worse. Sunday I was just like sore all over. I just felt super sore, and I'm like, I need to go to bed. I spend most of my day in bed. All right, hello, Sneaky Weasel. How we doing? Yeah, it was a little rough. Yesterday I felt still a little dizzy, like just to be more detailed. Um, I felt a little dizzy, but then I just slept a little more, and I feel a heck of a lot better now. So thankfully, I got all over all that. But yeah, the bad part is I wasn't productive at all this weekend. I didn't even get any of the grading done this weekend, so I'm apologies about that. The school didn't offer online learning for him. He was able to get a few assignments sent to him, but oh man, that's rough. That's rough. Does he have like math homework in like every subject under the sun? He's probably got a lot of homework to do in 2 weeks. All right. Yeah, Sneaky was a pretty rough weekend. But you guys have come out here for this stream, which I'm happy to see. I'm happy to see you guys come out for these streams. I gotta put on the other music. Put on the music here. Alright, let me put it on this thing. He's taking AP Stats and AP Calc. Ooh, the double. Did I get sick? No, I just got the effects of taking the booster and the flu shot together. Sneaky. So that's why I didn't. That's why I was kind of bedridden for like a couple days, and then yesterday I still worked, but it was just like yesterday I still worked, but I was still like a bit dizzy, so I went to bed a bit earlier. I know I missed a couple classes. I need to go back and watch the classes so I can get notes. Yep, that would be good. We're gonna be starting a new chapter here today, Jasmine. So at least you won't have missed a whole ton. Do I have anybody to take care of me? No, it's just me. You gotta suffer alone. Sometimes it's just how it is. It's fine though. Usually takes last time when I got the booster shot, when I got my second booster shot, when I got my second dose, that took me like a whole weekend to get over, so it wasn't so bad. I'm alone most of the time, so it's no big deal. I mean, it's been like that for a long time. Let's see here. I gotta take a look here. Alright. Yeah, alright. It's all good, it's all good. Alright, we ready to do this, ladies and gentlemen? Let's get started. Yes? Yes? Question mark? Or ready to get started? I hope so. Move this music slider down just a smidge. There we go. Alright. Let's do some intros, ladies and gentlemen. And let's get started. Let's go. Okay, let's get started today. Welcome back to Tuesday. Hope you had a nice weekend. Alright, so today, ladies and gentlemen, as mentioned earlier here, I do apologize for not grading this weekend. I was pretty much in bed all weekend, so apologies about that. I will be getting that done this week, getting your grades up to date. So apologies in regards to that, but you get the booster shot, you get the flu shot. Well, The bed was my friend all weekend. All right. Um, okay, so today, ladies and gentlemen, we are going to be continuing moving forward here in the textbook. Last time we finished up chapter 10, talking about the chi-squared distribution hypothesis testing. Okay, so again, I would highly suggest to go rewatch that video once you have the chance there. Jasmine, I know you weren't here maybe for the last class. I highly suggest to do that because, again, that one requires actual hand work, okay, to do. So you're going to need to know the process about how to do that. All right. So today, however, we're going to be doing, well, what are we doing today? We are doing more hypothesis testing. All right. So once again, we're in chapter 11. You're like, wait, what? Yeah, we're doing more hypothesis testing. Okay, absolutely more hypothesis testing. Now, exactly what type of hypothesis testing are we doing here today? Well, the hypothesis testing we're doing here today is not much different than what we talked about here at the beginning of chapter 10. Beginning of chapter 10, we talked about, say, population proportion. However, this time we're adding one more twist to the process. This time, let's go to the big board here. This time, we are talking about a two-population proportion hypothesis testing. All right, and that's essentially what we're doing here today in section 11.1. All right, so that's what's on the agenda here for today. So we're going to go ahead and get this done, plod along. We should be able to get this knocked out of the park, no problemo. Easy peasy, lemon the squeezy. All right. So let's go ahead and take a look here at each step as part of the process. We're going to look at an example, as you see off here to your right. All right, so we'll take a look at that. We'll solve for that particular hypothesis testing. We'll see how it works. Now, the key here is that we're going to have two sets of data, all right, two sets of proportions, all right? So, again, we could have, in a lot of cases, like two different groups, okay? Could be between just two random groups, for example, adults from before and adults after, whatever the case may be. But we're going to go ahead and see exactly how it will go. Okay. Okay. So let's take a good look here at number 19. All right, so number 19 says, in October 1947, the Gallup organization, actually, make this a bit bigger, sorry. I have a bad habit of you guys not reminding me. All right, here we go. You guys gotta remind me here. All right, so number 19, abstaining from alcohol. In October 1947, the Gallup organization surveyed 1,100 adult Americans. Was asked, are you a total abstainer from, or do you on occasion consume alcoholic beverages? Of the 1,100 adults surveyed, 407 indicated that they were total abstainers. In a recent survey, the same question was asked of 1,100 adult Americans, and 333 indicated that they were total abstainers. As the proportion of adult Americans who totally abstain from alcohol change, use the 0.05 level of significance. Okay, so let's go ahead and take a look here at this question and also go through the steps. Now the steps here that we have in this particular case is exactly the same as pretty much the same as what we talked about here in chapter 10. Now, of course, with minor modifications. So as we can see here, step 1, determine the null and alternate hypotheses. Now, in this instance, we are comparing two population proportions, one from the first group and one from the second group. Okay, so we have pop P1, which is the population proportion of group number 1, and P2, which is going to represent the population proportion of group number 2. Okay, so again, we just have two different groups of people. And by the way, just to let you know, they don't need to be the same size, okay? So although this question here has the same amount of people of 1,100, it doesn't necessarily mean that both sizes have to be exactly the same. All right, you could have 400 people for the first one and 750 people for the second group. That's entirely plausible. Now, the one thing that we have to look at here, of course, is if we're going to take a look at our alternate hypothesis, we can have less than, bigger than, or not equal to. But now that order matters, again, P1 is less than P2, P1 is bigger than P2, or P1 is not equal to P2. Again, reflecting our left, right, and two-tail here appropriately. Talk about the type of test, and talk about the level of significance here, which is alpha. All right, we'll get down to this part here, because this part here is rather interesting. So, talk about that. Let me grab my paint tool here real quick. Okay, so let's use it on our problem here. All right. Let's take a look at our null hypothesis here. All right. So one thing that I want you to notice here. All right. One thing I want you to notice here about the null hypothesis, we'll come back to the actual problem here in a second, is that the null hypothesis is static. Okay, meaning to say the null hypothesis is something that is not going to change. We're just going to make the assumption that both proportions are equal to each other. That's all we're going to do. So I'm not putting in any numbers in here for this. I'm saying that the proportion for group 1 is equal to the proportion of group 2. That's it for the null hypothesis, okay? That will always be the null hypothesis here for all of these type of problems, okay? For these double proportion types, all right? So unlike what we did here in the last chapter where we said, okay, well, the proportion is equal to this number here, this actual population proportion of a number of 0.52 or something. Well, not in this case. We're just going to assume that they're actually equal to each other. All right. Now, of course, the thing that is different is naturally going to be the alternate hypothesis here. According to our problem here in number 19, so for number 19, what is the alternate hypothesis? So for number 19, what is the alternate hypothesis? Do we have less than, do we have bigger than, or do we have not equal to? What do we got? Yeah, less than, bigger than, not equal. Vince says less than. Let's see. I would read that possibly one more time there. P1 is bigger than P2. So we'd say bigger than. Well, I got not equal to. All right, if it was not equal to, what would give that away, Alyssa? What would be your, what tells me if it's not equal to? Well, you guys tell me. You give me the carrot, but that's nice. But how do you know it's not equal to? Okay, alcohol change, that's correct. All right, very good. So it's that very last two words here. Has a proportion of adult Americans who totally abstain changed, okay, from alcohol change. That's correct. That's why in this case here, P1 is not equal to P2. Okay? So that is correct. All right, very good. All right, so just got to be careful about that wording here once again, just like we talked about here last time. It's going to certainly play a role here as well. All right, let's go to step 2. Let's talk about the type of test. What's our type of test? What type of test do we got here? Not equal. All right, pretty simple, right? All right, so it's the two-tailed test. There you go. Easy peasy. All right, and step 3 here, we're given the level of significance. So let's go ahead and write this down. All right, so we have 0.05. All right, so far so good. There are our first 3 steps. Perfect. Okay. All right. Let's move on to step number 4. All right, step 4 here. Okay, Step 4 here, admittingly, we are going to find the test stat. Now we're going to come back to this question here. We're going to absolutely need some of these numbers here, for sure. All right, now if we want to compute the test stat, here is the formula here for the test stat. You can, as you can see here, by the formula for the test stat, that, my friends, is pretty bad. Okay, without question, it's pretty ugly. All right, I mean it involves three types of P's and some sample sizes here. So you have the population proportion for group 1, population for group 2. You have P hat, which is x1 plus x2 over n1 plus n2. Okay, you got some square roots floating around in here. In any case, you can pretty much tell, well, this ain't too nice, at least in terms of a test stat. Now, for the sake of what we want to do here, it does look really bad. Okay, 100%. It does look pretty bad. But what you see here on the screen, there is one important thing here from step number 4. Although the formula here is ugly, no question. And once again, just like the things that we kind of talked about here in the first couple of parts of chapter 10, again, we don't want to go ahead and manually enter all of these numbers in. However, we do want to take some very important numbers as part of the process, because we're going to use the calculator here to find this particular test stat as normal. All right, so the thing that we want to find here specifically is we want to find these 4 numbers here: x1, n1, x2, and n2. Okay, so we want to find those specific numbers here. Again, these are going to be in relation to the proportion that we have here. All right, so again, x1 is the number of people who said yes for group 1, n1 is the sample size of group 1, x2 is the number of yeses in group 2, n2 is the sample size for group 2. So if we go back to our problem here, these are the numbers that we want to identify for our test stat. We're going to definitely need these numbers here, so having them down will be fairly important. All right, so if we take a look here at number 19, x1 here is going to be 407. So we're going to just name the people in 1947 group 1 out of n1, which is 1100. And x2 will be, again, the people that they were asked today. X2 would be 333. And n2 here would be also 1100. Okay. All right, now these are indeed important numbers here as part of the process. All right. Any questions so far about that? Any questions? Okay. No? All right. Easy peasy. All right, so let's go ahead and write down the test stat here. I'm not going to write out all the work for the test stat because it's insane. But you get the idea. All right. Now, the next part here for step 5 is going to find the p-value. All right, so we're going to find the p-value here in this instance. Now, how do we find the p-value here? Let's go over the step here. So we're going to use the calculator here in this case. Again, we're going to use the 2-prop z-test, okay? 2-prop z-test on the calculator here to determine said p-value. Let's go ahead and do that together right now, and we will see how we can acquire our answer. So let's get out our calculators here. Okay. Okay. So let's make sure everybody has their calculator here. Type got it in the chat once you have your calculator out in front of you, and we'll go ahead and get started. Make sure everybody's on the same page here. All right. All right, good stuff, good stuff. Okay. Let's go ahead and, oh, okay, Alexis has it. I'll make sure everybody has their calculator here. Good, good. This will give me a good roll call for making sure everybody's on the same page here. Okay, so let's go ahead and start with the calculator portion. All right, so we're going to go ahead and hit the stat key here. All right, so let's hit the stat key. I'm going to go over to tests. Okay, and we want to, again, let's go over this here. It says, again, we want 2-prop Z test, okay? So that's going to be number 6, okay? 2-prop Z test here, which is going to be number 6. All right, so I'll put that in the chat. Okay. We're going to go ahead and hit enter on that. Okay. Now, no matter if you have the old school calculator, new school calculator, it doesn't matter. You'll see this same submenu here. All right. And as you can see here, the way it is listed, all the numbers that we have here from step 4 are going to be pretty much put in that same order. As you see there, we have x1, n1, and we have x2 and n2, okay? And these are the respective numbers that we have stated here from our 2 groups. And this is why we write them down here for step 4, so we can easily plug them in and then see what we get. So again, we have 407 for x1, 1100 for n1, 333 for x2, and 1100 for n2. Now, once again, just like we had from before, again, the type of test is incredibly important. Okay, so we said this was a 2-tail test, right? So again, it is written in the same order as it was, but kind of in the other functions. So again, 2-tail, left tail, right tail, okay, in that order. Again, 2-tail, left tail, right tail in that order. So obviously we want 2-tail here, so we're going to keep it on not equals to P2. But again, as long as you understand that, again, defining the type of test so you know which one to highlight, that's just as important. And then we'll go ahead and go to calculate. All right. So let's make sure that first and foremost here, let's type in cool in the chat, and to make sure that we got the same answer that you see here on the screen. So type cool in the chat if you got it. Type cool. All right, let's make sure everybody else got it here. It's Sneaky. Sneaky, did you get it? See, everybody else here kind of good here. Yeah, just got it. Okay, good. Good. All right, just want to be sure everybody's on the same page. Anybody having trouble? Hopefully not. I can see most people have it, so that's good. Okay. I typed the wrong number. Oh, okay. That's fine. That's fine. That's why I asked Sneaky, because why everybody be on the same screen here, okay? Alright. Now let's take a good look here at what we see. Now, the only things that we care about here is we actually will only care about these first 2 numbers here. So just like it was before, the first 2 numbers are the only ones that really matter here for what we want to be using. So the first number here, we see the Z number here. This is going to be our test stat. So our test stat here is going to be 3.3393. Okay, so if we go to 4 decimal places here, that's going to be our test stat, 3.3393. There we go. No problem. Now, remember how it works from previous. Again, our p-value here is 8.4012. So 8.4012 times 10 to the negative fourth. Remember that e to the minus 4 is representative of times 10 to the negative fourth. So again, that's equivalent to 0.0008401. Okay, remember it's not 8 as a probability or a p-value, okay? Not 800%, because that makes no sense, but again, it's a pretty small number here. Alright, so that's our test stat here, 3.3393, and our p-value here being a pretty small number at the end of the day. Alright, the rest of these numbers here are more relevant toward each individual group, like what the probability is, or what p would be the proportion, excuse me, of each individual group, and then looking at somewhere in between, and then looking at the sample size, you get the general gist. Okay, really not hard. All right. Any case, those are helpful for the test stat, but we're not here to really worry about that. All right. Now let's go ahead and talk about step 6. Okay, so step 6 is to make our comparison. Again, same comparison as it was before in the first couple of sections of chapter 10. That was again, just making that last comparison. If the p-value is less than the level of significance, all right. So that's all we want to do here. Let's answer the question here is 0.000840012. Less than the level of significance here, which is 0.05. So yes or no, is 0.000840012, is that less than 0.05? Yes or no? Simple question here, hopefully. All right, the answer is yes. So Vince says we reject the null and accept the alternate. That is correct. Very good. That is our conclusion here. 100% right. Reject the null and accept the alternate. Where we get the level of significance? The level of significance is given to you in the problem itself. So you don't need to find that. It's just given to you. So let me go back to the book. So it's given in this last line here. Use the 0.05 level of significance. So yeah, level of significance, remember, is not something that we go ahead and find. It's given to us in every problem that we're going to be making the comparison with. Alright, so that's nothing that you have to worry about at any time in the process. Again, though, I do make everybody state it as a separate step, because, again, we will be using it as a comparison tool at the end of the problem, so it is there for reference just in case if you forget. Okay. Yeah, of course. Any questions about that, anybody? Or that example, I should say. Hopefully that's pretty easy. Question mark. Man. Typing no has been a problem for everyone in class. I got it. All right. Okay. I mean, I don't know what to tell you. The critical values. The critical values for what here, Alexis? I'm a little confused by the question here. We're not finding critical values here. We're just finding the p-value here in this case. Now, there is a critical value method, but that's well, actually, I don't know. They asked in the homework to find the critical values. Would you use N1 or N2? You'd have to use the sample size here, though. Let me see. What problem is that in the notes there? Oops, I didn't mean to do that. Number 1? Oh. Yeah. Let me see. It's a fair question. What if I go stronger? What if I get higher? What if I start doing things I know I will regret? I will make my own. It's a fair question to ask. I will do my best until I get put under. Let's take a gander. Let me see if let me check that. Okay, fine. Okay, that's fine. Alright, so the, I will say this. Okay, let me put it this way. Where is this? Alright, so this is what you see here. No, that's fine. That's fair. It's fair. It's a fair question. If this next test covers chapters 9 to 12, does that mean that the final exam is going to be on anything we learned this whole semester? Yes, the final exam is a comprehensive final. I've said that from day one. It's been a comprehensive final. But all the questions on the final are all questions that you have from the previous tests. So there isn't anything brand new from the test so all I did to make up the final exam, just to be as transparent as possible, is I just took random questions from each exam and I just plopped them into one exam, and then I called it a final exam, and that's all I did. So if you go over the review test, like the actual practice tests for all 3 tests, then pretty much any one of those questions can appear on the final exam, and it'll be exactly that type of question. So, yeah, there's no, like, hidden stuff with that, really. Okay, so for the critical value for this one here, for the critical value for this one, in this particular case, you want to use the type of test. So you use the type of test, which is 0.10. The type of test, which is a two-tailed test, pardon me. And you also use the level of significance here, which is 0.10. Right? So if we were to do, like, let's say they have an example here. I'll show you what they mean. So you could go through here, and if you do a two-tailed test, what's important here is actually going to be the notation here. In a two-tailed test, it would be like alpha over 2. So essentially, you would do 0.10 divided by 2, and that would equal 0.05. Right? That's what it would be. Now, you look in the table here, which is, we did talk about this table before. We're talking about these critical values. And that is on A15, I think. Making sure I get the right page for you. Here, A15. Make sure it's A15. Oh, not A15. A14, pardon me. So find the critical values here. This is why I need to look. Yeah. You can find the critical values here on page A-14. Alright? So, if I were to look at this here and I say, oh, wait, let's look at A-14 here, and I wanted to see, hey, what my critical values are going to be, well, let's take a look. And so, I'm going to go to the book. Come back to the book here. Go back to the e-text. Search A-14 here. So that was this table right here. So I don't know if you remember this table that you see right here. And all we have to do here is then take a look down here. Use the critical values here at the very bottom of the table. So what you want to do is you want to look at the very bottom of the table here. And 0.05, in this case here, that would be this column right here. 0.05. We look down here, and that would be 1.645. So our two critical values here would be minus 1.645 and positive 1.645 based on that notation there. This is for a two-tailed test, so you're going to find two critical values here. If it's for a left tail, by the way, so I'll just point this out here for critical values. Two-tail, you take alpha over 2, so take the significance divided by 2. Right tail, you take it basically straight up. Okay. Hang on a second. I need to be a little bit more precise, Alexis. Almost there. Right tail, significance level straight up. And then left tail, because again, that's what this says here. This is the area in the right tail, so you just need to be a little bit careful about that. Left tail will be, the left tail will be fine. Left tail, I think, is the same. Yeah, I don't think it matters. Left tail and right tail will be significance level straight up. So. It'll just be the negative value of that, though. Typically. Put that down there. There we go. All right. So hopefully that'll cover all the cases there, Alexis. Okay. All right. All right, cool. Okay. All right. Any other questions before we move on? Got a few more things to talk about here, but make sure that we're cool. Okay. No. All right. That's perfectly fine. Okay. All righty. Okay. Are we gonna need the chart for all the problems? No. No, you won't. Just that one part of the problem. Yeah, but you don't need it for all the problems, no. I'm just gonna point that out there. If you want to, there will be one part here. I didn't really talk about this too much here, but again, there's like conditions that you can follow here in order to do two population proportions here. That's here on this page, on page 527. So on page 527, this is for one of the parts on the questions here, is like asking, can you actually do the hypothesis testing here? These are the conditions to do two population proportion hypothesis testing. And the reason was I'm not really going over it because it's pretty much the same that we talked about here before. Again, the samples have to be independent, have to be random samples. Again, one of the things is NP times 1 minus P has to be bigger than or equal to 10 for both population proportions. So again, that's why we have this. Again, it's pretty much the same as we talked about here last time. And of course, both samples have to be less than the 5% of the population at hand. So again, it is that is a requirement here. They're pretty much the same three things that you talked about here when we first talked about population proportion back in chapter 10. So nothing has changed in that regard in terms of the conditions that you need in order to actually find these. So there are three conditions. There are three conditions here that you'll need to follow. All right. But that's for just one part for one question. So just to cover our bases, we'll just briefly talk about that. All right. In any case, let us talk about something a little bit more important, because there's a few more things that we certainly need to discuss. So let's discuss about that right now. All right. We'll talk about that. That is definitely on the table. All right, so next. All right, next. All right, so that's for hypothesis testing here, but in actuality, we have two more parts that we need to discuss besides hypothesis testing here. We may do another part here, but we actually will talk about confidence intervals here as well. So there is confidence intervals here when we talk about two population proportions. So we did confidence intervals previously with one population proportion in chapter 9. And we also talked about hypothesis testing here. Now we're doing both at the same section here with two population proportions. So that's the question here. How can we do confidence intervals with two population proportions? Now, as it says here, we're going to use the calculator. We're going to use specifically the 2propZN to determine the confidence interval with the given information and confidence level. All right, so we're going to do a specific problem here, right, just to kind of highlight a couple of important things. So let me go to that particular problem. It's not the problem I want. Where is the problem? Oh. What? Hang on a second. I saw the problem I wanted earlier. I can't find it again. Oh, there it is. Okay. This is the one I want. Number 22. All right. Let's do number 22 here together. And we will do this. All right. Body mass index. So the body mass index, BMI, of an individual is a measure used to judge whether an individual is overweight or not. A BMI of 20 and 25 indicates a normal weight. In a survey of 750 men and 750 women, the Gallup organization found that 203 men and 270 women were normal weight. Construct a 90% confidence interval to gauge whether there is a difference in the proportion of men and women who are normal weight. All right, good stuff. So, in this case, let's take a look here. And again, they split it up between men and women. That's fine. Now, regardless of whatever the two groups are, we're just going to go ahead and state our X1N1 and our X2N2. Okay. So the men could be group 1, the women could be group 2, whichever way you want to write it, it doesn't really matter. All right. So what do we have here for, say, X1? X1 here could be the men. So that could be like 203 men out of 750. And then we could have the women here. We could have 270 women out of the 750. Would have that. We're also given a confidence level here. So we just make note of that. The confidence level here is 90%. Okay, so we know that for a fact. Okay. All right, so let's go ahead and put that in the calculator here. Let's take out our calculators once again. All right. Now, all of you should have your calculators here from before, so let's go through this carefully and together. Make sure we get this all correct. All right, so we're going to go ahead and hit the stat key here once again. We're going to go over to tests. Okay, this time we're going to scroll down a little bit to letter B. Now, letter B says, again, 2 prop z int. Okay, so 2 prop z int is going to be our guy here. All right. And I want you to go ahead and hit enter on that. All of you should see, no matter what calculator you got, all of you should see this submenu here. Okay. Oh, sorry. I didn't mean to do that. Okay. Now, let's enter in our respective numbers here. So 203, 750, 270, and 750. Our confidence level here is going to be 0.90. And let's go to calculate. Okay. Now, first and foremost here, type "got it" in the chat if you have these exact numbers on your calculator. Let's make sure everybody has it first. Make sure everybody says "got it" in the chat if you have these exact numbers here. All right. Vince, Jasmine, Alyssa, Alexis, Thody. All right, Alex. All right, good, good. Victoria, Sneaky. Hopefully both of you have it as well. All right. I know Sneaky's maybe a few seconds behind, but that's okay. All right. Now, if you got this answer here, I want you to take a look at what we can see. There is one big difference between the confidence interval that we see here and the confidence intervals that we've seen in the past. One of the biggest differences is the answer itself, because the answer itself is rather unusual. The answer itself is negative. Now you're probably saying, hang on a second. The entire thing is negative? And I'd be like, yes, actually it is. This is true. So you can have negative values in your confidence interval. This is perfectly okay. All right. So note, again, negative values are okay. All right, so even though I would be like, it looks like negative, percentages or whatever, I don't know what you want to call it, but really we're comparing two proportions with each other. So that's why, in this case, having a negative is okay, since we're looking at both proportions here, and just making a comparison. All right. Now, of course, one of the things that we need to talk about here, when it comes to confidence intervals, is naturally the interpretation of said confidence interval. That is going to be the most important part. So getting the numbers here, not too hard to plug it into the calculator, but for us, we always have to answer what exactly does it mean in the context of the given problem. All right, so that's what we're going to look at here next. So we do have these numbers here. That's all well and good. But looking at the context here, this is talking about the difference in proportion of men and women who are normal weight. So, if we look at the guy here. Okay, so here we have the confidence interval, negative 0.1286 and negative 0.05. We can say, just based on the context we have here, let me bring up the book. I'm just going to bring this up. All right, so we are 90% confident, again, that's being a 90% confidence interval, that the difference between the proportion of men and women who are normal weight is between negative 0.1286 and negative 0.05. Okay? That's the way we want to kind of write it out. Is that the difference between the proportion of men and women who are normal weight is going to be these two things right here. All right, any questions about that? So the only difference here is that, again, the interpretation always comes down to, excuse me, little feeling the effects of the weekend here. So talk about the difference between the proportion of men and women, and that's how we can do the confidence interval. All right. Any questions? All right. Now, one more thing that we need to talk about here is something that we did talk about when we first discussed population proportions back in Chapter 9. Back in Chapter 9... nope. Got it, Vince. um... Okay, so back when we talked about Chapter 9, when we talked about confidence intervals of population proportions, we had discussed about determining the sample size, an appropriate sample size, given you wanted certain circumstances to happen. So maybe, again, you wanted a certain margin of error. Okay, you wanted the certain margin of error, or you wanted particular you wanted particular results, or again, you're comparing it to a past precedent. whatever the case may be, to maintain, the credibility of your results. So let's take a look at number 3 on the handout. So number 3 says, and I'll put this on full screen. Number 3 says, how do we determine the sample size for two population proportions? All right, so let's say we're trying to figure out, what would be an appropriate sample size if we were to start from scratch. All right, let's say we're starting from scratch and we're trying to compare two sample sizes. Maybe for example, I'm going to one part of a state and I go to another part of a state and I ask, which candidate you support or whatever. All right, maybe I want to ask the same number of people, but I need to know exactly what would be the appropriate amount of number of people I could ask in terms of their support for whatever candidate. All right, so the way we want to do this is, of course, you have two cases, just like we did here back in Chapter 9. The two cases is if P is given here with the margin of error, then in this case, both sample sizes here, that's why N1 and N2, would be the first proportion P1 times 1 minus P1 plus second proportion P2 times 1 minus P2 times this critical value here, again the critical value we've talked about here earlier, divided by the margin of error quantity squared. So that do we need to write down this formula? This would be very helpful. Yes, Vince, I would not disagree. This formula here would be very helpful for you. Hey, Yusuf, how we doing, my friend? Thanks, Yusuf, I appreciate that. I'll go visit his stream after this. Yeah, so this is if we're given a p-value here, if p is given. So if we're given both proportions, all right, and we have some past precedent we're going to make a comparison to or whatever, then we can go ahead and work with that. If we're given two comparisons, we can figure that out. All right, the second formula here is we basically cut it in half. We say if p is not given, again, we just kind of cut it in half. We say take 0.5, multiply it by the critical value divided by the margin of error, quantity squared. All right, so that's if p is not given here. Then if we find our appropriate sample size, we're just gonna 50-50 it. All right. Now again, the critical values here appropriately. As I mentioned here, this is found on found in Table 7. This is on page A14. So this is what we talked about earlier. So as was asked earlier, this actually again has I would like the letter A, please. All right, on page A14 in the back of the textbook. So please be able to find that there. So again, 90% here will have the critical value here of 1.645. 95% will have the critical value of 1.96. 99% will have 2.575. All right, so those are the three major ones there. Again, any other different critical values here you can find in the back of the book, or you can reference Google. That will also be helpful as well. Okay, so let's go ahead and take a look and see exactly how this will work using an example. I'll put this actually over here for right. Alright, here we go. Okay, so let's take a look here at number 30. Let's see which one I want to do. I don't know. Whichever one really matters. Let's go with 33. Alright. Let's do number 33 here. Alright, a physical therapist wants to determine the difference in the proportion of men and women who participate in regular, sustained physical activity. What sample size should what sample size should be obtained if she wishes the estimate to be within 3 percentage points with 95% confidence, assuming that she uses prior estimates in 1998 of 21.9% male and 19.7% female, Alright? Or she does not use any prior estimates at all. Okay. We're going to use our formula here. We're going to kind of go back and forth a little bit. So let's go ahead and write down some of the information here. Then we'll come back and use the formulas here in just a second. And this is for 33. Okay, so in this instance, again, we are given a few things here. First and foremost, we have a margin of error. Here has to be 3 percentage points. So again, margin of error must be 0.03. That's a given. All right, we are also given a P1 here, the first group here, which is for males. That'll be 0.219 for 21.9%. And we'll have P2 here, which is going to be 0.197. Okay, so we have P1 and P2 here, respectively. And then finally, we have the confidence level here of 95%. And again, if we go back to our handout, the critical value associated with 95% is going to be 1.960. So I'm going to go ahead and write that down right now. All right. Now, given this information here, now we can go ahead and we can see exactly what we get here in both instances. All right. So for letter A, let's use the first formula because we're given prior estimates. I'm going to bring back the formula here. All right, here it is. Okay, so we have n here is equal to, first of all, P1, which is 0.219, times 1 minus 0.219, plus 0.197, 1 minus 0.197, and then we'll multiply that by our critical value here, which is 1.96, divided by 0.03, squared. All right, so that's what we have here. This is our formula. Now let's plug this into the calculator. Let's see what we get. Now, if you're going to plug this into the calculator, I'm just going to let you know. All right, so I'm going to move this around. I know there's a lot of moving around. So, all right, now if you're going to plug this into the calculator here, I'm just going to point this out here for you guys. If you want, you can try and enter this in all at the same time. You can. Although, again, I just want you to recognize to not get it wrong, you just want to be able to add these two things up first, and then you can multiply. So basically, what I'm saying is that first do the first part in the brackets just as a kind of a separate step. So you'd be like, okay, 0.219 times 1 minus 0.219. 219. Okay. And then plus, and then you would do 0.197 times 1 minus 0.197. Then we hit enter here. So you're going to get some random answer here. But then you could just multiply this by the end part here. And this makes it significantly easier so you're not worried about where parentheses need to go and stuff. You can just do it as two separate steps. Okay, we need to square this. We need to do answer times that. That'd be helpful. Let me insert that. That would be helpful for reasons. There we go. Alright. Okay, and so here we get 1405.3, or again, we round up, so this would be 1406. So again, always, don't forget, always round up. Okay, any questions about that? Any questions? Hopefully this has been okay. Not really? Alright. Hopefully today's been pretty easy so far. Got just do letter B, which is if we're given no estimates. Alright, so letter B is even easier. Let's say we're not given any estimate at all. Again, we're going to use the second formula here. Let's say we're not given anything. Again, the second formula here is even easier than the first because there's no other numbers to float around. That's going to be 0.5 times the critical value divided by the margin of error squared. Alright, so just 0.5. So here we have, and here is equal to 0.5. 0.50, whatever you want to call it, times 1.96 divided by 0.03 quantity squared. So let's see what we get. So we get 0.50 times 1.96 divided by 0.03 quantity squared. And so here we get 2134.2, which of course will round up to 2135. Where did the 0.5 come from? The 0.5 came from the formula itself, Victoria. That is right here. Essentially, because we're not given any p here, Victoria, we just basically 50-50 it. That's essentially what you're doing here. So it's like, if I don't know what p is, we'll just say both of them are just half, and then that's fine. So basically, if you take half times half, it's 0.25. You take 0.25 plus 0.25, it's 0.5. So that's essentially, you're just basically saying, all right, if I don't know what it is, we'll just cut it in, we'll just take 0.5, we just do it at 50%, and then that should be fine. So basically, you're taking a rough guesstimation at the end of the day. So you're kind of fudging the numbers a little bit, and you're making like some sort of a halfway compromise. That's effectively what you're doing here for the 0.5. Otherwise, if you want me to show you the math about exactly where the 0.5 comes from, I can show you that too. But that's what the 0.5 represents, so... any questions about that last example there? I hope that answered your question there, Victoria, though. That's what I'm hoping for. If that answered your question, then fine. If not, then I can certainly elaborate a little further if you'd like. Okay, cool. All right. Okay. Good. Okay. All right. All right. So those are the three guys. Yeah, those are the three types of questions that we want to talk about here in this section. This is entirely section 11.1. Now, really quick for you guys here, would you like me to go over any additional examples for any of the three questions? Because admittingly, each one of the questions is a little different. First one is hypothesis testing, second one is confidence interval, the third one is finding a sample size. So it's like, it all uses proportions here, of course. Alright, but we're talking kind of three different things, and so if you want me to go over another example of any one of the topics here, we can do that. If not, that's okay too. So, hypothesis testing, confidence interval, and sample size. The confidence interval? Yeah, we could do the confidence interval one. Sure. Let's do it. Let's take a look. All right. Here we go. All right. All right. So let's look at 27 then, Alexis. All right. So I just randomly chose one, and we're just gonna run with it. All right. Okay, so 27 says, all right, the Iraq War. All right, so in March 2003, the Pew Research Group surveyed 1,508 adult Americans and asked, do you believe that the U.S. made the right or wrong decision to use military force in Iraq? Well, the 1,508 surveyed, 1086 believe that the U.S. made the right decision, all right? In August 2010, they asked the same question of the 1,508 adult Americans, found that 618 believed that they made the right decision. All right, so we're going to look at letter B here. Construct and interpret a 90% confidence interval for the difference between the two population proportions. All right, so as you can see here, one of the important things I want to point out here is they notice they have P of 2003 and minus P of 2010. So just if it helps for these problems here, define your groups. Okay, so just say, okay, group 1 here is equal to 2003. Okay, the 2003 people. And that group 2 is the people that they asked in 2010. Okay. So, if we have this here, all right, let's write down our set of data that we need here as part of this process. So our first group, okay, X1 here will be the number of people who said yes to the question. All right, in this case here, that happens to be 1086 because that was asked in 2003. And we have we have 15, is it 1508? Yeah, 1508, sorry. And then we have the 2010, which is the group number 2. So we have 618. And so we have that out of the 1508. Okay, let's do that on the calculator here. Oh yeah, forgot. Let's not forget. Confidence level is kind of important. Just a smidge. So we have a 90% confidence interval. So let's put that on the calculator. Let's see what we get. We're going to hit the stat key here. We'll go over to tests. I'm going to scroll down here to 2prop z int. That's letter B here, Alexis. All right. So 2prop z int. And we'll go ahead and put in the numbers here appropriately. So the numbers here appropriately are going to be 1086, 1508. You have 618, 1508. Confidence level here is going to be 0.90 for our 90%, and we'll see what we get. Okay, so here we see our confidence interval, 0.28 0.214 and 0.33855. Okay. Now again, it could be negative, but in this case here, the first group had much more support than the second group. So again, hence why it's positive here in this case. All right. Now the question comes down to how do we interpret this confidence interval, at least within the given context of what we are given here in this problem. So if we go back to our handout, you can take a look at the general template. So the template here, again, says we are 90% confident. We can say that for sure. Actually, yeah, let me just put this here. We are 90% confident that the difference... Hey, you know what? What I'm gonna do? What I can do. Not sure why I'm doing this. My handwriting is pretty atrocious, so I'll put it here. It would be helpful if I had it. Alright, so we are 90% confident that the difference, so I'm just following the same thing here, between the proportions. So notice I'm using the same exact language. We're 90% confident that the difference between the proportion. So nothing changes. The only thing that changes, of course, in this case is the percentage. The important point that we list here, again, the difference between the proportion of, in this case here, people who supported the Iraq War in 2003 and 2010 is between, and then 0.28214 and 0.33855. Okay. We'll just put it, you know what? Okay, and that's how we can go ahead and state the interpretation here behind said confidence interval, just like so. I hope that made sense there. Any questions about that? Any questions? Yeah, no problem. As long as they're able to clarify. Vince. I bust out my emoji for that. There. Sure, Victoria, absolutely. Should we complete 11-1 for homework? Yes, that would be very preferable. All right. Any more questions before we wrap it up here for today? Nope. All right. Good stuff. All right. All right. All right. Okay. If there are no questions, I might have questions later, but no, okay. You know where to find me, Jasmine. It's not like I'm going anywhere. So, I'll be on Discord if you guys need me. You guys know where to find me. But, in the meantime, guys, I'm gonna be sticking around here because Victoria may has some questions for me. But I will say this: I'll go to the other screen here. All right, I want to thank everybody for coming on out here. Thank you so much. All right, thank you very much for coming on here once again. That will be effectively the end of section 11.1. I promise I will get to your grades here this week. I apologize if I was feeling under the weather due to the shots and stuff. So, but feeling a lot better here today. So I'm just getting back into the swing of things. But I will see you all on Thursday, okay? So Thursday, we will come back and we will continue moving forward, all right? So with section 11.2, we're getting down to close to the end. Oh, just this chapter and chapter 12, and we are DONE done. And that is it, okay? So very close to being done, and we're getting there. So promise you we are going to be finishing here on time, all right? Thanks, Jasmine. Appreciate that. All right, we'll see you Thursday, everybody. Have yourself a wonderful day. All right, we'll see you then, everybody. Take care of yourselves. All right, bye. Oh yeah, right. Last intro here. As always, everybody, stay safe, stay healthy, and most importantly, stay sane. Thanks, guys. Have a good one. We'll see you later. I'm forgetting everything. All right, have a great one, everybody. Take care of yourselves. Bye. All right. In any case, Victoria has questions for me, or a question for me, on section 10.2, I believe. Yes. Okay. Let me bring up 10.2. Victoria, what question from section 10.2 did you have issues with? Okay. Take a look. Yeah. All right. So this is my question here. Now, of course, I know that your numbers are going to be a little different, but still, at least we can talk about doing a couple of these parts here. All right. So, got the calculator here. So let's test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. All right. So is np times 1 minus p is bigger than or equal to 10? So in this case here, p is equal to 0.4. All right. N is equal to 250. So we're going to take 250, multiply that by p, not 2250, but 250. Multiply that by p, which is 0.4, and we'll multiply that by 1 minus 0.4. We'll do that, and let's see what we get. So we get 60, so is this bigger than or equal to 10? The answer is definitely yes. We'll select that, and that is true. All right. We use the technology to find the p-value here. Now, in this case, we're given a proportion, and this from being section 10.2. So what I would like you to do here, Victoria, is to go ahead and hit the stat key here. All right. We are going to go over to tests here. And what we want to go underneath here is number 5. Number 5 says 1 prop z test, okay? So go to number 5 for 1 prop z test. Okay. So if you notice here, underneath 1 prop z test of Victoria, p0 is where we're going to put in 0.4, because that's what p is equal to. we'll put our x value here, which is given to us as 115, and our n value, which is given to us as 250. Now, we also have to tell the calculator here, Victoria, on the type of test that we have. Now, the type of test that they specifically give us here is bigger than, again, a right tail test. We have to tell the calculator we want a right tail test. So again, as you see here, we have a two tail test, a left tail test, and a right tail test. We want to highlight the right tail test. Again, two tail, left tail, right tail. Highlight the right tail test and hit enter. Okay, and before we hit calculate here, because I know the question was, where do I enter in all these numbers? Make sure that you're on the same wavelength as me. So, you with me here so far, Victoria? Are there any questions so far? I hope you're able to enter that into your own calculator just fine. Okay, great. All right, let's hit calculate here together. Okay. Now, really quick, Victoria, do you have the same numbers on your calculator that I do? Okay, remember to write those down, Victoria. That's why I have them as steps. That's why I have them as steps in the process on the handouts. Be sure to write the right, the right calculator function with the right thing, okay? So here we have a p-value here. Okay, good. Because if we're having issues, again, I don't disagree with you, Victoria, that sometimes it could be confusing because they all kind of look the same. But we just got to be careful so we don't keep making the same mistake over and over again. So I just want you to be sure to, you can be consistent. You don't have to worry about being super confused. All right, so the p-value here, let's put it down. That's 0.026 because they want 3 decimal places. All right, so check that answer. At least for me, that's correct. And then we compare that to the level of significance, and so we reject it. Yeah. Okay, so for me, I rejected the null hypothesis. Okay, fine. It depends. I don't know what your numbers are, Victoria, but maybe it's just, maybe, I don't know. All right. Any other questions there, Victoria? Already got it down? Perfect. Any other questions, Victoria? No? Okay. All right, great. Well, you know exactly where to find me, Victoria. I'll be on Discord. If you need to ask me a question, please feel free, okay? And I'll be more than happy to help you guide you through another problem, all right? All right, you have a wonderful day, all right, Victoria? Take care of yourself. And as for everyone else, I hope everybody has an absolutely fantastic day as well. I'll be back here in a few hours to do another stats test. Oh, that's 102. So, have a great day, everybody. We'll come back here at, I'll be back at 4 o'clock, at least for today. But for those of you watching this video, I'll be back on Thursday. All right? Take care, everyone. We will see you later. Have a great one, everyone. See ya. Bye. Bye. Bye.